Good morning, students. So, once again, I welcome you all for this session. So, in the last class, we have studied different elements of a force, that is, magnitude of force, point of application, line of action, and direction. So, these are the four elements of a force required to give the clear picture of a force. Okay, now let us move on to the next important segment of this session, that is a system of force. Okay, when you can call a system of force, so a group or set of forces is called as system of forces. So when a single force is acting on a body, we cannot say it is a system. So okay, so when more than two forces are acting on a body, or a group of or number of forces acting on a body, then we can say that there will be a system of forces. Okay, then next is line of action of force. Already we have seen that what you mean by line of action. So line of action is nothing but it is a straight line, okay, along which a force will be acting. Okay, yesterday we have seen that dotted lines. Okay, so dotted line indicates the line of action along which the force will be acting in the vertical direction or horizontal direction, right? Now the next important term is classification of force system. So how we are going to classify the force system? Okay, so there are basically four classification. One is a coplanar force system, okay, then non-coplanar force system, then concurrent force system, non-concurrent force system, then collinear force system, and parallel force system. So these are the classification of force system. Now what do you mean by this coplanar? Okay, co means same plane or single plane, right? The forces which are acting along the same plane are called as coplanar force system. Now example you can take here. This is one plane, okay, this is another plane, okay, right? So some forces like F1, F2, F3, these are acting on this plane. Or you can take two sheets of paper. One paper is like this, another paper is like this. Okay, so three forces acting on this paper, that is F1, F2, F3, and F4, F5, F6, another three forces acting in this plane or in this sheet of paper. Now based on this we can classify the force system is either coplanar or non-coplanar. Coplanar means the forces which are acting in a system, right, along the same plane are called as coplanar. Now if you consider only these three forces, F1, F2, F3. So all these three forces acting on this sheet of paper or on this plane only. So these three forces are called as coplanar force system. If you consider only these three forces, it is coplanar force system. That is F1, F2, F3 are acting on the same plane, right? These are coplanar force system. Now again if you consider only these three forces, okay, that is F4, F5 and F6. Again F4, F5, F6, if you consider only these three forces, again these three forces are acting in this plane or on the same plane. Then these three are also called as coplanar force system, right? Suppose if you consider all the six forces, okay, these three forces acting in this plane and these three forces are acting in this plane. Okay, so if you consider all the six forces, I cannot say it is a coplanar because three are acting on this plane and these three are acting this plane. So on different planes they are acting. Okay, so if you consider only these three forces, yes, these three are coplanar force system. If you consider only these three forces, yes, they are coplanar forces system. If you consider all the six, I can say these are not coplanar, these are non-coplanar force system. Okay, three are acting on this, three are acting on this because they are acting in the different planes. then this system is called as non-coplanar force system. See, if you consider F1, F2, F3 coplanar force system, if you consider only these F4, F5, F6 coplanar force system, but if you consider all the 6, 3 are acting this plane, 3 are acting in the different plane. So total this system is non-coplanar force system. Okay, so based on this I can say that if all the forces in a system acting in a single plane or same plane, then the force system is called as coplanar force system. Okay, otherwise it is what? Non-coplanar force system. Right? If all the forces in a system do not lie in a single plane or same plane, then it is termed as non-coplanar force system. So depending upon the number of forces in a plane in a system acting, if they are all are acting on the same plane, then it is coplanar, right? If forces are acting in a different plane, then it is non-coplanar force system. Co means same plane. Okay, this is one classification. Next is concurrent force system. Concurrent force system. Now see again, there are 5 forces or 4 forces you can consider: F1, F2, F3, F4. So direction may be the change, right? This is acting outward direction, it is inward direction, this is inward direction, this is outward direction. Now see, whatever these dotted lines for each force, these dotted lines are called as line of action. Okay, so this force F1 will be acting in this direction, that is along this line of action. F2 is acting in this direction, that is along this dotted line only. Then F3 like this, F4 is like this. So there are 4 forces acting at particular point O. Okay, now what I can say that this is a concurrent force system. So why? Right, if the line of action of, say these are dotted lines are the line of action, if the line of action of all the forces in a system pass through a single point, see the line of action of all these forces passing through this point O. Okay, so this system is called as concurrent. Okay, if the line of action of all the forces in the system pass through a single point, then this system is known as concurrent force system. Okay, the line of action of all the forces will going to meet, or it will going to pass through a particular point or a single point, then this system is called as concurrent force system. Right, now again observe this. Right, so this is F1, this is F2, this is F3, F4. The line of action of all the forces will be different, they are not going to pass through a single point. So this system is called as non-concurrent force system. Okay, if the line of action of all the forces in a system do not pass through a single point, then that force system is called as non-concurrent force system. Okay, then similarly collinear force system. Collinear force system. The line of action of all the forces in a system lies along the common line. Okay, line of action of all the forces in a system lies along a common line or a single line. It is known as collinear force system. Okay, same line. Collinear means same line. Now see, there are two forces F1 and F2. This is in the opposite direction, whatever it may be. Right. So the line of action of this and the line of action of this F2 passing through the same point or same line. The line of action will be acting along the same line. Then this system is called as collinear. The best example is when you play that tug of war. Okay, tug of war. So some people standing on this side and group of people standing on the other side of that rope. So these people will going to pull the rope in this direction, right? The group of people standing on this side, they are going to pull the rope this side. So the line of action of these people will be acting in this direction, and the line of action of force applied by the people on this side will be along this line. So the line of action of all the forces, right, lying in the same line, along the same line, then that system is called as collinear force system. Okay, then the next classification is parallel force system. Okay, as the name suggests, right, the line of action of all the forces will be parallel to each other. Now see, F1, F2, F3, F4 acting, right, the line of action of all the forces will be parallel to each other. Okay, then this is called as parallel system. And again, F1, F2, F3, this is also parallel system, but this is called as like parallel force system. Okay, and this is called as unlike parallel force system. So no doubt both are parallel only, but it is like parallel and this is unlike parallel force system. So what do you mean by like parallel? No doubt line of action of will be parallel, but the same direction, forces are acting in the same direction. See, the direction of all the forces will be same. So this is called as like parallel force system. And this is unlike. See, the direction of each force will be different. This will be acting upward, this is downward, again this is upward, this is downward, right? The direction will not be same for all the forces. So this is unlike parallel, this is like parallel force system. Okay, so same thing, this is a nothing but a non-concurrent force system. See, if you consider, right, the line of action will be different, they are not going to pass through a single point. So it is an example of non-concurrent force system and it is a parallel force system. Okay, it is like parallel and it is unlike parallel force system. Next, now we are going to study related to this force system some principle, the important principle of these forces. So the first principle is principle of physical independence of force. Okay, what is this principle? Principle of physical independence of force, or you can say that law of physical independence of force. So what this principle states? See here, independence of force, physical independence of force. So it states that the action of a force, okay, action of a force on a body is not affected by action of any other force on the body. Now see, if you consider a body which is subjected to single force, one force is acting on a body. So the body is subjected to a single force and that force will be having the effect on that particular body. Okay, so each force will be having the effect on that particular body. If I add another force, okay, if I add one more force, the effect of that force will be, right, not going to affect the effect of the first force, because the effects of individual forces will be different. Okay, so that is physical independence of force. Each force will be having its own effect on that particular body. So that is called as principle of physical independence of force. So each force will be having their own effect on that particular body. Okay, then the second principle is principle of superposition of force. Okay, principle of superposition of force. It states that the net effect, okay, the net means the total effect of a system of force on a body is same as the combined effect of individual forces acting on the body. So again the same, it is giving to the same meaning what the physical independence of force says. Okay, what it says, it states that the total effect of a system of a force on a body is same as the combined effect of individual forces acting on the body. So net effect, now assume that there are four forces acting on a body. Okay, the four forces acting on a body, then because of these four forces there will be a total effect on the body. So that total effect is called net effect, that is F net is equal to, so this total effect is nothing but what? Addition of effect of individual forces. So F1 will be having its own effect, F2 will be having the own effect on the body, F3 will be having own effect on F4 will be having its own effect on the body. So if we add effect of F1 plus effect of F2, then F3 plus F4, so this is equal to total effect of a system of forces. So this is called as superposition of force. Okay, then this principle is also stated as following form, that is the effect of given system of forces on a rigid body is not changed by adding or subtracting another system of forces. So when there is a set of forces acting on a body, that system will be having the own effect on the body. If I add one more set of forces, right, so that effect will not going to be, right, affected by the first force system. Okay, the four systems will have their own individual effects. That is called as principle of superposition of force. And now the third law or principle is principle of transmissibility of forces. This is important, remember, principle of transmissibility of forces. Okay, now take an example here. Again, this rigid body. So I'll going to take 2 points, that is point A and point B. Now the force is applied at A, right? Force F of magnitude F applied at A. Okay. Now according to this law of transmissibility, what do you mean by transmissibility? Right? So the force which is acting at point A now, right, can be replaced at some other point. So can be replaced at some other point without changing the effect of body. Means without changing the state of the object. Now see, right, so initially the force is acting at point A. So because of this force, what happens? The body will going to move in this direction, correct? The body, now see here, this example. So in the first case, the force is acting at point A. So because of this, the body will going to move in this forward direction. But what happens? I don't want the force to be at A. Okay, I don't want force to be at A, but the force to be applied at some other point. Instead of A, at some other point. I want at B now. Right? I want the force to be applied at B, but condition is that the state of the object should not change. Means if it is moving in this direction, means it should move on the same direction by replacing force F at A now at B. Even though if you apply the force at B, the body should move in this direction only. Then that is called as transmissibility of force from one point to the other point. So how this is possible? Now see, in the first initial stage, the force F is acting at point A, and because of this, the body is moving in this direction. Now what I am going to do? So this is second case, force will be at A now. Okay, then I am going to apply it at B, right? So I am going to apply equal and opposite force here. Okay, so equal and opposite force at B now. Again of same magnitude, remember, of same magnitude. This is F, means this will be F, again opposite F. So these are the forces, equal and opposite forces applied at B now. Right. So by applying these equal and opposite forces at F, I am not going to change the state of the object, because this is in these two are opposite direction and of same magnitude, F and F. So these two will going to get cancelled, because if you consider this is plus direction, this is minus direction. So plus F minus F, these two will going to get cancelled. So if they get cancelled, automatically this will going to remain, this only force will going to remain as it is, like this. So by applying equal and opposite force at B, I am not going to change the state of the object. Okay, now totally how many forces? The force F at A now, and these two opposite forces at B. Now right now there are three forces here. Okay, one is F at A, then in this direction this is force F at B, and this is opposite direction, force F at B. Now observe this force F at A and this force F at B. Okay, so these two are again equal and opposite, right? Equal force and opposite direction of same magnitude. This is also F, this is also F. So again these two will going to get cancelled. Equal and opposite forces of same magnitude will going to get cancelled. If these two get cancelled, what is remaining? This force, this F force will going to remain. Okay, now observe this figure and this figure. Okay, what you can say? Initially we have started the force F at point A. Now, where is the force now in this sketch? Force F at B, right? And observe the magnitude. This is also F, this is also F, same magnitude, right? So, in this case also, the body is moving in this direction, but when I shifted the force F at B, still the body is moving in this direction only. So, this is called as transmissibility of force. Okay, the force is transmitted from point A to the point B without changing the state of the object. Still the body is moving in this direction only. So then to transmit the force from one point to the other point without changing the state of the object, what are the conditions required? First is we have to apply, now see this figure and this figure. Now initially force F at A. Now when I transmit it to B, what is that magnitude? Magnitude is same as that of previous force. This is F means this should be also F. Okay, and see the direction. This is the direction of force F is in this direction, and replaced force is also same direction. It is not applied like this opposite. No, same direction, same magnitude. Magnitude should be same. That is, if it is F means this is also F. It is moving in this direction. It is applied in this direction means this should be also same direction. So magnitude should be same, direction should be same, and one more important, the replaced force, this is a replaced force, should be applied along the same line of action. See, this is the line of action, dotted line. Okay, I cannot apply the force here now. Okay, so along the same line of action, if you apply the same magnitude of force, same direction force, then without changing the state of the object, the force can be transmitted from one point to the other point. So this is called as principle of transmissibility of forces. Okay, now see here, let F be the force acting on a rigid body at point A. According to the law of transmissibility, this force has the same effect on the state of the body as the force F applied at B. Now, replacing this force with some other point, that is at point B, yes, the effect cannot be changed unless same magnitude will be applied, same direction will be applied, and at the same line of action will be applied. So I cannot apply the force here, I cannot apply the force here. Even I cannot change the direction of this, I cannot apply the force like this. If I apply the force here, then the body will going to move in this direction now. Okay, it should be moved in the same direction, means same magnitude you will going to apply, same direction you will going to apply, and another important thing is same line of action. The replaced force should be along the same line of action. So this principle is called as principle of transmissibility of forces. So remember these three principles. One is principle of physical independence of force, principle of superposition of forces, and principle of transmissibility of forces. Okay, this is important question they may ask in the examination. And before this, what you have studied? Classification of force system, that is coplanar force system, okay, non-coplanar force system, concurrent force system, non-concurrent force system, collinear force system, parallel force system. Okay, so these are the classification of force system, and these three are the principle of forces, that is principle of physical independence, principle of superposition of force, then principle of transmissibility of forces. Okay, so hope you understood this session. Okay, if any doubts are there, feel free to call me or Tejashwini madam. Okay, so we will clarify your doubts. Okay, so please go through this session. Okay, so after the completion of this, I'll going to circulate the notes also. Don't worry about the notes, right? So we'll going to circulate the notes, but please go through this. Try to reproduce the whatever the same thing you explained in points wise. Okay, right? Don't buy these. Okay, try to understand the concept. Okay, so thank you very much for attending this session. Have a good day. Thank you.